Hello everyone, I'm Shivani, third year ECE student from SPMEB. Thank you MSc Information Technology for giving the embedded system internship. We are explaining about automatic washing machine simulation. Contents of this contents of this project was C programming, microcontrollers, embedded systems, what is washing machine, requirements, picsimlab, mat, mplab xide, xc8 compiler, picgenius, pic 165F877A, CLCD, tactile switches, matrix keypad, timers, washing machine simulation using picsimlab. C programming. C is developed by Dennis Ritchie and C is structured programming language. C supports function that enables easy maintainability of code by breaking large files into smaller modules. Comments in C provides easy readability. C is a powerful language. Features of C language is fast and efficient, modularity, statistically typed, general purpose language, rich set of built-in operators, libraries with rich functions, middle level language, portability, easy to extend, procedural language. And the number system in C programming are there are various types of number systems in mathematics. The four most common number system types are decimal number system, binary number systems, octal number systems, hexadecimal number systems. Decimal number systems are the base is 10 and the binary number system base is 2 and the octal number system base is 8. Hexadecimal number system base is 16. And the keywords in C programming language was auto, constant, double, float, int, short, struct, unsigned. And the break, continue, else, for, long, signed, switch, bold. Case, default, enum, go to, register, size of, type, def, volatile, characteristics, do, extend, if, return, static, union, while. And the process of compilation was first we send the C programming file to source file and the preprocessor that process the input data to produce output and the compiler compiles the programming file and the assembler was do the programming that converts assembly language into machine code and object and to linker. Microcontrollers was explained by Deepika.
Microcontrollers. Microcontroller is a small computer in a single integrated circuit containing a processor core, memory, and programmable input and output peripherals. It is designed to perform specific tasks in embedded systems such as controlling devices and managing inputs and outputs in electronic devices like appliances, automobiles, medical devices, and more. They are commonly used in projects requiring automation or interaction with sensors and actuators. Embedded systems. An embedded system is a combination of hardware and software which is particularly designed for specific application, and it is a programmable and it has a specific functionality. While embedded systems are computing systems, they can have range from user interface to graphical user interface. Embedded system structure design consists of sensor, analog to digital converter, digital to analog converter, actuator, processor, and application specific integrated circuit and memory. The analog to digital converter which converts analog signal to digital, and the digital to analog converter which converts digital signal to analog, which means continuous signal. The memory which is RAM, ROM, EEPROM, anything else which can be used to store data, and application specific integrated circuit is the perform some specific application. Examples of embedded systems, the daily common used applications are cell phones, telephones, washing machine, set-top box, etc. What is washing machine? A washing machine is a home appliance which is used to wash laundry. There are different modes to control the washing machine. They are load select knob, water inlet select knob, mode select knob, program select knob. The load select knob which contains low, medium, high, which decides how many number of cloths Water inlet select knob. In water inlet select knob, it consists three modes: hot, cold, both mixed. Mode select knob. In mode select knob, it consists of two: save mode and normal mode. Program select knob. In program select knob, it consists four: heavy, normal, light, delicate. Heavy means the cloths are very dirty. Normal means normal dirty cloths. Light means for light dirty cloths. Delicate silk cloths. The next topics will be explained by Sivatija.
These are the requirements which are used for washing machine output screen, power on screen, washing program screen, water level screen, start screen, function screen, completion stated screen, microcontroller, buzzer, motor. picsimlab. picsimlab is a software tool used for stimulating and debugging PIC microcontroller programs. It provides a virtual environment where you can write, test, and debug code for PIC microcontrollers without the need of physical hardware. This can be used for learning, prototyping, and troubleshooting embedded systems projects before deploying them onto actual hardware. This is a picsimlab logo. MPLab XIDE. MPLab XIDE is an integrated development environment created by Microchip Technology for programming and debugging microchip PIC microcontrollers and DSPIC digital signal controllers. It provides a comprehensive set of tools for writing, compiling, debugging, and optimizing codes for these microcontrollers. This supports multiple programming languages including C, assembly, and others, and offers features such as project management, code editor, simulator, and hardware debugging capabilities. It's widely used by the embedded systems developers for developing applications for microchip microcontrollers. XC8 compiler. The XC8 compiler is a C compiler specifically designed for microchip PIC microcontrollers. It is a part of MPLab XC compiler series, which includes compilers for various microchip microcontroller families. It translates C code into machine code that can be executed by PIC microcontrollers, allowing developers to write firmware in a high-level language rather than assembly language. This makes development faster, more efficient, and easier to maintain. The XCR compiler is often used in conjunction with MPLab XIDE for writing, compiling, and debugging PIC microcontrollers firmware. Picgenius. Picgenius is a hardware platform designed for learning and experimenting with PIC microcontrollers, particularly PIC 167F877A. This is a popular 8-bit microcontroller for microchip technology known for its versatility and widespread use in various embedded system applications. The PicGenius platform typically includes various input-output interfaces such as UART, SPI, and I2C. It provides a hand-on base for enthusiasts and students to explore microcontrollers programming, circuit design, and interfacing. Users can write firmware for using these programming languages like C or assembly and then upload the code to the microcontroller for execution in the Big Genius hardware. This combination of hardware and software enables practical learning experiencing in embedded system development. Next slides are explained by Deepika.
CLCD. CLCD means character liquid crystal display. The character liquid crystal display is a type of display technology used in electronic devices such as monitors, televisions, smartphones, and other gadgets. It employs liquid crystal cells to produce images with color. In a character liquid crystal display, each pixel consists of three subpixels, typically colored red, green, and blue. By varying the intensity of these three primary colors, a wide range of colors can be generated. The liquid crystal cells control the passage of light through them, modulating the intensity and color of light to produce images. Character liquid crystal displays are widely used due to their ability to produce vibrant colors, high resolution, and relatively low power consumption compared to other display technology such as CRT, which means cathode ray oscilloscope or cathode ray tube, or plasma displays. They are commonly found in devices ranging from smartphones and tablets to compute monitors and large screen televisions. Data processing in character liquid crystal display. Data processing in character liquid crystal display could refer to how data is handled or manipulated within systems that utilize color liquid crystal displays. Character liquid crystal displays. Here's a breakdown of potential interpretations. Display data processing. CLCDs receive data signals from devices graphics processing unit or other control circuitry. This data is processed within the CLCDs control electronics to generate the appropriate signals for each pixel, controlling the intensity and color of light emitted by such subpixel. This process involves converting digital data into analog signals to drive the crystal cells and produce the desired images on the display. Input data processing devices. Devices with CLDs often involve user interaction such as touch screen, smartphones, or tablets. Data processing in CLCD contents could involve handling user input data such as touch gestures or button presses and translating them into commands or actions within the device software or operating system. Integration with data systems. In certain applications, CLCDs may be used as part of a large system that involves data processing. For example, in industrial control panels or medical devices, character liquid crystal displays may display data collected from sensors or other sources. Data processing in these contexts could involve collecting, analyzing, and presenting data on the CLD for monitoring or control purposes. Data transmission and display. CLCDs can be used to display data transmitted from external sources such as computers or network connected devices. Data processing in these cases involves receiving data over a communication interface, example HDMI, display, USB, and processing it for display on the CLCD. In summary, data processing in CLCD encompasses various aspects of how data is handled, manipulated, and presented within systems that incorporate character liquid crystal displays. The specific detail would depend on the application and the role of the character liquid crystal display within the system. The next topic will be explained by Renika.
Tactile switches. In matrix keypad, we need to configure rows as output and columns as input. When designing pull-down interface, R1 is 10 times greater than R2. Triggering methods. Edge triggering, level triggering. Edge triggering means edge triggering is used for only one task. Level triggering is used for multitask, that is continuous task. Bouncing effect. This is a metal plate and terminal. Spurious pulse detection while pressing or releasing the tactile switch is called the bouncing effect. Matrix keypad. Matrix keypad is nothing but a normal keypad that we use for the computer to give input. It is also consists of characters and letters. The keypad buttons are arranged in such a way that each button is unique in combination with row and column. When button is pressed, it creates a connection between specific row and column in matrix, allowing the system to detect the button. Matrix keypads are often used in various applications like electronic devices such as calculators, remote control, security system, and access control panels. Embedded systems. In embedded system, we use matrix keypads to do microcontroller based projects. Industrial control panels, matrix keypads are used in industrial settings for data entry and control purposes. In security systems, Key code entry systems and alarm panels often use matrix keypads for user authentication and arming or disarming operations. Matrix keypad can vary in size and configuration. Generally, the size of matrix keypads are 3 by 3, 4 by 3, and 4 by 4 grids. Timers. Generally, we use timers to create time delay. It has three models. In this, we use three models like PWM, pulse width modulation or pulse generator, counter, and PW or PP measurement, etc. Tick up, tick, that is up count or down count. Quantum, that is system clock setting. Scaling, pre or post. Resolution, register width. The micro mode and grill mode are under the operation mode, and the timer is set with matrix key pass to clear and to enter. To toggle the LED 8-bit resolution is required. Washing machine simulation using picsimlab software. This slide explains about the power owning of the washing machine. Next slide. This slide explains about the programs or the modes that our washing machine has. This slide indicates the washing programs. This slide indicates the water level. This slide indicates the start and stop option of the operation of the washing machine. This slide indicates the warning that door is open, please close. This slide indicates that program is completed, please remove clothes. Now let's see the actual working. In board, we'll select Pick Genius. In microcontroller, we'll select Pick 16F877A. Click on File and load the hex file. To power on the washing machine, click on RP4, that is key 5. We are seeing now the washing machine is on. Now this indicates the washing machine is on. We have to select the load. To navigate, we should click on RB4. Sorry, RB3. This indicates whites, stain wash, eco cotton. To select program, long press on RB3. Dry only, wash only, aqua. Long press on RB3 to get water levels. One minute. Now we have this indicates the water level, auto, low, and medium. To navigate, we should press on RB3. To start the operation, we should press on RB4. Now we can see the cooler is rotating, that is the motor is rotating, and this function is including in three parts: wash, rinse and spin. Now the program is completed and it is indicating remove clothes. Thank you for giving me this opportunity.